Welcome back, everyone. In this video, we're going to discuss clustering, which is a very common technique in any system. It's a technique you apply onto a specific component where you increase the amount of servers that exist, but we're going to do it in a very different way than what you might be thinking. Usually, this is discussed in comparison to load balancing at a high level because they serve two different functionalities, but we're going to go into how clustering actually works, but we're also going to talk about how clustering and load balancing is often used in conjunction. So looking back at load balancers, we discussed in the last video that with a load balancer, these servers act independent of one another. Each server has no idea about any other server in the system. It doesn't care. Server 1 doesn't even know that server 2 or 3 exist. Server 1 simply receives requests and then it processes them and then it moves on. It is highly independent and completely unaware of anything else around it. And this is the same is true for server 2 and the same for server 3. Now, clustering does not replace load balancing. Instead, what we need to do is we need to zero in to one of these servers. So let's take server 1 as an example. Clustering is where you have a bunch of servers that act together and are completely aware of each other and work together as a cohesive single unit towards some objective, meaning that you are essentially relying on the resources of multiple servers together in order to achieve some desired objective. So you can imagine if server 1 inside was composed of multiple other servers that are all working in conjunction. Now here, there are a couple caveats to this. The first is that each of these servers is known as nodes. You can see these nodes as, again, just a different terminology we use to capture what an independent server or a virtual machine is doing. But they're all cohesively working together. Oftentimes, these servers, even though they're different servers, you want to treat them as a singular entity. So inside of our diagram, it should be a singular server. And as a result, why they're nodes and not servers is because you want to see these 5 servers together as one server. They all respond to one IP address. They'll share one IP address. They're treated as, again, a single entity. As a result, another thing that we need to do then is you need to assign a leader node. Now, let's say we chose node 1 to be the leader. In this case, what happens is that when the requests come in, they all go through node 1. Node 1 then acts like a load balancer, and it will forward these requests evenly between the remaining nodes. But the difference between load balancers and clustering is that in load balancers, outside of this cluster example, I mentioned that none of the servers are aware of each other. Inside of this cluster, all the nodes are not only aware of each other, they're constantly communicating with each other, and they're constantly syncing their states. By syncing their states, if any one node goes down, then it's very easy for the remaining nodes to pick up the work that that one was doing. There's no latency between this, and that's the whole idea of clustering. You're trying to reduce node-to-node communication, but you're also making it extremely easy for any of the nodes to replicate the state of a node that went down. They're, again, working in conjunction towards a singular objective. And all of these nodes hold the exact same resources. They don't share resources per se, but they have the identical resources. They're identical servers. They're identical nodes. So there are a couple configurations to think about as well. As I mentioned before, when we were talking about single point of failure, we talked about redundancy. So essentially it just means that there can be passive nodes as well as active nodes. What we're seeing here is 4 nodes that are all active and sharing the load. But this might not be necessary. You may be really overutilizing resources to keep 4 nodes active if the traffic doesn't even amount to the amount required here. What we can do is maintain passive nodes. Now, nodes 4 and 5 are considered the passive nodes. They're there, but they're still syncing with nodes 3 and 2. There's still communication between those nodes. They're just not being routed the actual traffic of requests. Instead, what happens is that if nodes 3 or 2 go down, then nodes 4 and 5 will become active. So this is the whole idea around keeping these passive nodes. It's mainly more so used for resource management per se, in terms of managing your costs. But this is clustering. You can see how clustering can be used in conjunction with load balancers out in the system. Each of these servers, while in this higher level diagram, are not aware of each other. So server 1 doesn't know server 2 doesn't know server 3. Inside of the server, either server 1, server 2, or server 3, they are their own cluster of many node servers inside. Inside of the cluster, they're aware of each other. Outside of the system, amongst this high-level diagram, these servers are not aware of each other. That's load balancing and clustering. It's just a method to increase the reliability of your system. It's scaling. It's very similar to horizontal scaling, essentially. You're just increasing the amount of resources available in order to deliver on some specific objective. So that is clustering. Now that we understand clustering, let's move on with our course.